Welcome to class. Today we're going to learn about circuits. You might be asking yourself, why should I care about circuits? Well, one reason may be because of makerspaces. I don't know if you've ever heard of a makerspace. A makerspace is a place where people get together to make things. It's a creative space that's often used in STEM and STEAM types of projects. So these have been created all over the world and have become especially popular in schools and elementary schools and local libraries. In fact, there's a makerspace at the elementary school just down the road from me, and it has pulled in students from all over because they're interested in going to the makerspace. Wonderful place to go to let students experiment, to create, and to learn how things are made. Another reason you might be interested in learning about basic circuitry is because of the new SEED standards. SEED stands for Science with Engineering Education. Well, what that means is that science education standards are no longer just going to be focused on the science aspect of things. That's still important, but they're going to start integrating engineering into that as well. Well, part of engineering is learning about circuitry. So much today depends on electricity and making sure that our electronic components work. So it's really important that students learn about electricity and they learn about circuits in that process. So with makerspaces, learning about circuits will expand the amount of things that they can do. And at the same time, that's going to be meeting several standards in our new SEED standards in the state of Utah. Another reason that you might be interested in learning about basic circuitry is because it does such a great job at helping students get a hands-on experience with learning, just like the microbits did. In fact, learning about circuitry is going to expand your repertoire of the types of things that you can do with microbits. And finally, the last reason is the best reason for me, which is because it's so darn fun. It's really cool when you see a light light up for the first time and you know that you're the one that made that light work. So let's go ahead and talk about some of the components that you're going to need. Earlier in the semester, you should have picked up a bag. We called it our maker kits. We made these for you at the beginning of the semester. You should have those. We're not going to use everything in there, and in fact, you don't even need to use everything in your maker kit for this project. We put extra stuff in there so that you could have enough that you could do something with and let your creativity wonder where it might. But what we are going to use today is we are going to use a CR2032 battery, which you should have in there. We're also going to use an LED, and you'll notice you've got about 10 LEDs in there of varying colors. Here I've got a blue, a clear, a yellow, and a red LED. You're also going to need for the project that you create, you're going to need some sort of conductive material. Now that could be aluminum foil, it could be conductive paint, which is really cool, fun stuff, or it could be this copper tape, which we've included a couple of feet of copper tape in everybody's kit in order to make their cards. So that being said, let's get to it. Let's make your first circuit. So what you're going to need for this is you're going to need, let's see if we can get our camera to focus on that. You're going to need this CR2032 battery, and you're also going to want an LED. Now what I'm going to do is I'm going to create a simple circuit between the LED and the CR2032 battery. Now the way the LED works is you'll notice in that last picture that we showed you, you can see the components on the inside of this. There's a little gap there. When the electricity jumps that gap, it lights up the LED. You'll also notice that there are two prongs coming out of the LEDs. You've got a shorter prong and a longer prong. That's really important to determine which is the shorter and which is the longer, because the longer prong is the anode, or the positive side, and the shorter prong is the cathode, or the negative side. Now, electricity, the way that we're going to learn about electricity here, likes to flow towards the negative side. So it flows away from the positive and toward the negative. It's going to be really important as we put together our components throughout this project to understand which is our positive side and which is our negative side. In fact, that being said, you'll notice here on your battery, if we can get the camera to focus on that for a minute here. I'll hold still. All right, you can see there on the battery that there is the positive side. You can see it says that the top of that is positive. It also says that it's 3 volts. 3 volts is the same as 2 AA batteries or 2 AAA batteries. So this essentially has the same voltage as 2 AA's or 2 AAA's. It doesn't have the same amount of capacity, which means it's how much energy it holds because it's a smaller battery, right? Now, the negative side is rough. It doesn't say anything, but it's kind of our rough side. What we're going to do is I'm going to connect my LED to my battery. If you remember, I told you that the long side of the LED, the long prong, is the positive side, and the short is the negative. So what I need to do is make sure that that long prong touches the top, and the short prong touches the bottom. And once I do that, it lights up the LED if the LED works. In fact, I always like to test my LEDs at the beginning of any project just to make sure that they work. So I can see here that my red LED works as well. And now I'm going to test this yellow LED. And I'm going to test my blue LED. In fact, I can light them all up on here at the same time. Oh, I must have gotten something wrong, or my blue isn't working. So let's see what happens. I'm going to put this in here. Oh, and my blue works just fine. And then I'm going to test my clear LED, and I can get that in there as well. So I've got several LEDs. I know they work, and I know that this battery works, so I'm ready to go. Let's create our first card. If I were to create a fun little card that has a simple circuit, like the one that we just created, I can actually do that. Here's one that is kind of fun and popular. It's "Welcome to the Dark Side. May the 4th be with you" is the one that you see that I've got up on there, and it's got it's got this lightsaber, and the whole idea is I've got an LED up in here, and the prongs to the LED come out the backside, and I've got this battery taped to the back, and the goal is to connect the battery in such a way that it lights up my my lightsaber. And that's a lot of fun. It's about as simple of a circuit as I can create, and it is a great way of teaching that you need the positive to the positive and the negative to the negative, and it can light up an LED. So there's your first circuit. Let's look at simple circuits. If we were to get away from the battery a little bit, you can see here on this simple circuit, I have this simple circuit here. You see I've got the battery, and it's taped to my piece of paper here. And then I've taped something to the top, and I've taped something to the bottom. And the energy goes out through here, and you can see it. I've got both of the prongs, and I've got it lighting up the LED, and the circuit goes around and it closes. Now the word circuit actually comes from the word circle, right? It's the whole idea that I'm completing the whole circle as I go in there, right? And if I were to disconnect one part of the circle, it would no longer have the energy flowing all the way through, and it would no longer light up my components. So here's a first question for you. With this LED that you see on there, which prong is the positive prong? Which prong is the positive prong? Well, it's actually this one here on the right, because I can tell my battery has the kind of the textured side showing. And that texture side, as we learned just a little bit ago, that texture side is going to be the negative side. And the positive side actually has the words on it and tells you that it's positive. So I can see here that the positive side is down, which must mean that this leg coming out of here is the positive side, which also must mean that in this LED, this is the longer of the two legs. And then it connects here all the way around to the negative and flows, and we complete that circuit. So that's a simple circuit. There's another type of circuit, called a series circuit. And a series circuit is a lot like a string of Christmas lights that you might have used. All of the current is going to flow in one direction, and it's going to flow through the components, through every single component. So I can tell often by looking at a series circuit if there are gaps in the circuit like this. I've got a piece of my tape that doesn't connect to any of the rest of the circuit. That probably means that it's a series circuit, because what's happening is I've got all of the current is going to flow through here on the positive. It's going to flow through this first LED, and then it's going to connect to this otherwise disconnected piece. And this component is going to connect it again. So in a series, I have two or more components in a row that are connecting that and completing that circuit. So how can I tell if a circuit is a series circuit? Or what are some of the benefits of the series circuit? One of the benefits is it takes less material to create a series circuit than the circuit I'll show you in just a minute, right? One of the drawbacks is if any component along the line breaks, I've now or it doesn't work anymore, doesn't communicate that electricity, doesn't let it flow through, it stops any of the rest of the components from getting electricity. So like a string of Christmas lights, if I were to if this first light were to go out and electricity is no longer able to flow through it, then the rest of the lights after it are also no longer going to work, or rather they're not going to light up, even though they might be just fine. So let me show you here a common series circuit that you've probably seen a lot, right? This is just an extension cord. And in the extension cord, I've actually got my wire coming up one side, and I have two prongs, just like I have with my LEDs. Now, what do you suppose happens when I remove this prong from the wire here? Well, what I've done is, just like in this picture, I've actually stopped that circuit from flowing. And all that happens is the electricity is going to flow up through these two components here, and that completes the circuit and allows the circuit to the electricity to keep flowing, right? So that it flows up through here, it goes into whatever the electronics are, and the electronics uses the amount of voltage it needs, and it returns the electricity back through and completes that circuit. And then I've got my complete circuit with an extension cord. So that's kind of your basic series circuit. So what other kinds of circuits are there? The other kind of circuit that we're going to be concerned with here is called a parallel circuit. A parallel circuit is a little bit different than a series circuit in that it splits the current in two directions. Or it splits it into the positive side and the negative side. And those two sides, they don't touch, but the components complete the circuits for each of those. So let's look at an example here, and then we'll look at some physical examples. In this example here, you can see I've got this first light that's lighting up. And I've got the positive that comes off here, and I've kind of got the main lines. Then I've got branches that come off of those main trunks. So this is my main positive branch, and this is my main negative branch. Now the negative comes up here, and on both of these, we've got these negative branches, and they connect to the LED. So the power comes up through the positive, it hits that positive side, goes out through the negative, and back around as it completes that circuit. So what do you think would happen if this bottom, or this first light, broke and electricity was no longer able to flow through it? Well, if I were to trace a circle, I could actually see I'd still have a complete circle on the top light. So the bottom light going out doesn't prevent the top light from going out in a parallel circuit. And that's the main difference between a parallel and a series circuit. Another important difference is in a series circuit, the components get priority in the order that they go. So for example, that first component, that's going to have its opportunity to take advantage of all of the electricity that is flowing through there. So maybe it's going to use, let's say, 0.7 voltage, right? And maybe I only have 3 volts that's flowing through. If I've got 7 lights on that series, and each light in turn takes 0.7 volts, there won't be enough energy for that last light to pull the energy that it needs, right? So it's kind of a waterfall model in a series circuit. But in a parallel circuit, all of the lights get the same amount of energy. So let's see some examples of how this might work. One of my first examples here is a light-based telegraph. My son, who was a 5th grader last year, for the Living Wax Museum activity that they do at his school every year, he chose Samuel Morse of Morse code fame. So Samuel Morse created a sound-based telegraph. Well, my son created a light-based telegraph, where as you tap the telegraph, the LEDs would light up. So you can see here, this is actually just 2 simple circuits together. And I can see on over here between the B and the A, I've got the battery, and he's got a wire running out from the battery. Now that wire comes into this, it comes into the bottom of this tapping thing, and basically all we did down there is we put a piece of aluminum foil, and on the top, you can see the wire at the top comes into the top of that aluminum foil. Well, that means it's a broken, or it's an open circuit. When I touch down the tapper that I have in there, the aluminum foil connects together with those wires, and it completes the circuit, and it lights up the LED that we have here. So that completes that whole circuit. And then I just have another one going the other direction. So we could have a telegraph here that was going both directions. That was a lot of fun to make. And that actually addresses one of the new SEED standards, which is that students will be able to design a structure that communicates with light over a distance. Now this was a really short distance. We didn't use very long lights, but a telegraph, basically that's all it did, is it had telegraph wires and they used sound instead of light. As you tapped and as it completed the circuit, that's what happened with the telegraph. So that was a lot of fun. If you're interested in making something like this, we actually completely copied this project. You can see I've got a template that I used from the Maryland Science Center, and the instructions for that are here in the link. Another example is a name tag that one of my TAs built. So you can see here on this name tag, this was Megan, and she was a maker mentor for our makerspace that we had up and going before COVID kind of took that off the table. And she made a physical name tag here with straws and a few lights to light it up. So on the back side of this, you can see she has this little battery holder that's made out of paper. I'll show you how that works in just a moment. And you can see she has split the current, right? So if she's split the current and she's got a positive side and a negative side, what kind of circuit do you think it is? Hopefully you said parallel circuit, right? So this is our parallel circuit, and you can see here we've got the lights going down the middle. She's got 3 lights. And you can see on the front, 2 of the lights are lighting up, and the middle one isn't. So probably what happened is this crease here has made it so the legs aren't quite touching, contacting the way that they need to contact with that copper wire. But because it's a parallel circuit, it doesn't matter. The last light gets power, even though we've broken this circuit. There's still room for there's a complete circuit for the electrons to run along this last LED and the first LED. You'll also notice that they're both lit up equally, and that's because it's a parallel circuit, which allows its components to all get the same voltage across those. Here's another name tag that another one of my TAs built. I actually have this one right here. So you can see this is Elise's Maker Mentor name tag, and I'm going to light this one up, and you can see here she's got it where it lights up several different lights. Some of them aren't working, which probably tells you, oh, she also made a parallel circuit. As we look at the back, some of them I think we just need to touch it a little bit better. If I look at the back, you can see I've got my battery holder, which is a little paper battery holder. And in that battery holder, it's really cool how these things work. Basically, all it does is I come up here and I fold the positive and the negative pieces of tape on one side. And if I want to turn it off, I take that lid and put it in front of my copper, and no longer is it working. So it's kind of a nice little paper-based switch, as it were. You notice here she's got the copper coming at the top and the bottom. So she has split her current again, which tells us it's a parallel circuit. And then you can see this thread that's coming off it. That's actually conductive thread. It's got some metal in it, and that thread is what allows the current to flow through it. So she started with some copper tape and then ended with the thread. And I think one of the threads goes along the top and the other goes along the bottom, and then we've got some LEDs that connect those. So those are some good examples in practice of parallel circuits. Here's another parallel circuit example. This is from another one of my TAs, Mackenzie. And this was a fun little project. You can see here on the bottom right-hand side of this card where the battery goes. And that battery connects here to the positive side, so it's just going to put the flat side down. And as you fold over the card, it connects the battery, the top and the bottom. So you can see this piece over here, these 3 pieces of copper tape, they'll actually close this gap. So I've got a main trunk of positive that comes off this way, and then I've got these branches that all come off this way. And I also have a main trunk of negative that will connect to the top of the battery and comes out here, and I've got one branch running off of the negatives over here, right? So now that I've got that working on all of those, it's just the LEDs that connect those, and you can see here in this picture where 4 of those 5 LEDs are lighting up. I didn't quite get that last one down. I don't think it's quite touching as we go through that. So that's a lot of fun. You could create a card like this for your light up card. It looks more complex, but really it's just several lights all along this parallel circuit that she has created. This also goes, you'll notice here, I've put in the science standards that this goes with current science standards. This is a 5th grade science standards, is that students will understand features of static and current electricity, and this is current electricity. And I find that there's few better ways of helping students really understand how things work other than allowing them to be the creators of those things. Another fun example was from my son, who I told you he was in 5th grade last year. Well, this year in 6th grade, he told me that for Halloween, he wanted to be the scariest thing he could think of. Well, the scariest thing he could think of was a bad Wi-Fi signal. Go figure. You can see here he is with his code. He coded a microbit to, and we got some conductive thread to create this creation together. So you'll notice here, it's actually a really simple microbit program. He has it so you program the lights once, it does one thing, you hit the other light and it'll blink, or it'll turn on the bad Wi-Fi signal. So right here, you can see in this example, we have a good Wi-Fi signal. You can see here something really important that we did, and this is something I'm going to ask you to do, I've asked you all semester, is to make sure you decompose the problem to begin with. I will say we first created our first circuit on a piece of paper, and it didn't work. And I'm really glad that we did it on a piece of paper rather than first sewing it into his shirt and then finding out that the circuit that we created didn't work. So you can see the basic circuit over here on the bottom left-hand corner. The way that we made this one work is we actually connected it through the microbit. So I've got the battery, the CR2032, taped off to the side. It's not doing anything. You can see the battery pack for the microbit up here above it, and the microbit is lit up, and we connect the microbit. It looks like it's actually disconnected in this picture. We've disconnected one of the wires. But I just used those alligator clips, and there's 1, 2, 3, 4 rows of lights, just like in our actual product. So we created a prototype to make sure that we knew how it was going to work first, and that it would work. And this is just like the other parallel circuits. I've got a main branch coming off here for my positive, and I've got a main branch coming off for my negative, and those branches don't touch. But I've got, or those trunks, the branches that are coming off the trunks don't touch. You can see I've got the branches here for 1 negative, another 1, 3. I've got 4 of those for each side, and then we've just got the lights that connect each of them. So this first one was really just a simple circuit because it's only got 1 light that's on there. But then we can see I've got 3 lights, 5 lights, and 7 lights. So make sure you break down your card and the problem that you want to address before you go ahead and start taping things on and using up the components that are your precious components. Plan it out with one of the most important tools that you're going to have, right? In planning things is a pencil, right? So just plan out with a pencil, draw out, and say, okay, is that the circuit that I want? And then you can see here, I took some pictures as we were making this together. There's a negative side and there's a positive side, and they just follow the same pattern on this prototype that we built on paper. And you see it kind of labeled. Once we got all of the threads in place with this conductive thread, we just labeled them positive and negative and taped them down. And then we attached some wires at the end of it so that we could actually have the microbit controlling it. So here it is. This is actually his shirt. Kind of took a beating at Halloween. So it doesn't look quite as good. It was a lot of fun. Don't think it even fits him anymore. But you can see we've connected the wires to the microbit. And we connected 2 wires that came out here, and then they came back around through the ground. Now let me show you how that worked. Let me show you this working. In his Halloween costume, super scary. No internet.
No, it's no Wi-Fi.
No Wi-Fi, I apologize.
Completely different, Dad.
Yeah, no Wi-Fi.
Actually, they are.
We made this together. All right, so you can see that working. He was super thrilled. He got to walk around as the no Wi-Fi guy as he went and raided houses for candy this last year. Okay, and another example we have comes from a colleague of mine who was teaching at Purdue University, and he helped teachers at 19 different elementary schools in Indiana create and do circuit activities with their young students in 4th and 5th grade. And one of the activities they did is called a digital storyboard. And the way that a digital storyboard works is they help the students read a story, and then they create some sort of board out of cardboard that lights up or has motors and does different things that tells a part of the story that they had just learned about. So you can see in this example of a student, they've got the pictures here that they've painted. This paint is actually conductive paint. So this is kind of like our copper tape. And then the conductive paint, you can see, it's hard to see in this picture, but they actually then had some little wires going down each side of the lightsabers. And they've turned this on with their microbit. They don't have the Star Wars piece turned on. They programmed that to work with a different set of wires. As you can see, those wires kind of going behind in this other example. So those are some examples of things that you might do with elementary kids in terms of learning about circuits and ideas for circuits and things that you could do. I do want to take a moment to talk about troubleshooting, because just like with coding, you're going to need to troubleshoot, right? Troubleshooting is always part of the process, and failure is part of the learning process when it comes to creating things, which is really important. So a couple of tips to help you. First, always check your connections. Are the LEDs connected to the battery correctly? Do you have the positive connected to the positive and the negative to the negative? Try reversing them to see if things aren't lighting up and you think they should be lighting up. Reverse and just make sure you have things in the right direction. It's kind of a simple statement, but is your battery placed in the holder correctly? Make sure that battery is in there and that it's contacting the metal pieces or whatever the conductive pieces are that it needs to touch. And by the way, with that paper battery holder, if you're interested in Canvas, we put a link for how to create those. There's a great site that showed us how to create those super useful little battery holders. Third point in troubleshooting is your conductor. So for example, copper tape is making contact with the battery. Press it together to check. I found that with these paper things, they're pretty low-end components. So you have to do a lot of pressing together to make sure things are actually touching the way that they need. Is your battery dead? Right? Have you ran out of energy? So you've got voltage in here, and every time that you connect a light to it or some sort of component to it, you're drawing energy from that, right? Well, eventually that energy is going to wear out. So always test. If you think you should be getting some sort of light or some sort of action and you're not getting that, get another LED, put the positive and the negative on there, and just make sure that battery is actually working. Is your circuit completely closed? So check that circuit as it goes through. It needs to be a full circle, right? As you go through, everything should be completely closed and touching. And then are the positive and negative lines touching? So I told you before in that when we look at a parallel circuit, we don't want those positive lines to touch the negative lines. Well, what happens when those positive and negative touch, instead of going through the components, is you might get what's called a short circuit. Basically what's happening is the energy is taking a shortcut, because instead of going up and around the way that it should go, you've now touched a component to another, or let's say a conductive piece to another conductive piece that it shouldn't be touching, and it's taking a shortcut to get back home. Well, that's a short circuit, and that short circuit, what happens is the electricity then doesn't get up to where it should be getting up to, right? We don't want to short circuit things. We might also have a surge of power happen a little bit more. So let's test our knowledge right now and see how well you can identify different types of circuits, right? So here's an example of a desk lamp. And my question here, is this a simple, a series, or a parallel circuit? Hopefully you said that this was a simple circuit, right? Now it might sometimes be called a simple series circuit. You have what's here a switch, and the switch is basically, it cuts or lifts the circuit up from being touched. So we don't necessarily consider that an electronic component, because it's not going to be lighting things up or playing a motor or anything like that, right? So the switch basically turns the electricity on and off because it completes or it opens or closes a circuit, but then that circuit comes up around and goes through the LED and then comes back. So this is a simple circuit. What about this one? That is also a simple circuit, right? It's the same type of thing. Electricity comes out on the left-hand side. It goes through this switch that we have, which basically connects or disconnects the lines going through here. energy comes up to the positive side and it continues to flow towards the negative, and then we complete that circle. So those are two simple circuits. What about this one? This is a parallel circuit, right? I can tell that this is a parallel circuit because I've got the two currents that are coming off of the battery, and they each have these main trunks and the branches come off of them, right? So this is just like the prototype that you saw with my son's shirt. If we were to take this light off, the other light would still work, right? And this was a fun card that a child made for their dad, right? A little pair of eyes that lights up. What about this circuit? This is also a parallel circuit, right? So once I fold this end over and make sure that my two copper sides are touching, you can see over here I've got the switches that interrupt. They're actually called interrupters in some languages. I've got the switches that interrupt that current from flowing, but if they're turned on, you can see over here I've got the main branch, my main positive and my main negative, and then I've got the branches that come off those main trunks. And as they come off here, they'll light up each of these three lights. Now I can turn light 2 off and not affect lights 1 and 3. And that's because I'm running it off of a parallel circuit. And finally, we've got this one right here. What kind of circuit is this? You might have been tempted to say that this is a parallel circuit. It looks like there's a lot of material here. But this is actually just a simple circuit. It's not even a series circuit. Now let me show you how this works. Over here, when you fold this line together and have the battery, this copper tape touching the battery, you can see on the positive side it flows up here. And if I have the paperclip turned down the way that it's turned down right now, really all I'm doing is completing this one simple circuit up top. I've got one light and it's going through that light up there. Now the whole idea here is that we can rotate this paperclip so I can light up something being red, yellow, or green. Now if I switch the paperclip to the yellow, I've now actually interrupted this line that I had the circuit going up top for the red, and I've completed the circuit for the yellow. So this is kind of an interesting way where the switch isn't just a two-way switch or a switch that works on a single line, but the switch actually switches between the different circuits as we have them on here. But in the end, it's just a simple circuit. And all of these ideas, I'd be remiss if I didn't tell you where these came from. These came from a great book by Andrew Miller called Paper Circuits from Makerspaces. This is free for purchase, not free for purchase, it's for purchase. You can download it from makerspaces.com, or you can download an electronic version or a digital version, or you can actually download a paper-based version if you would like that, to be able to have the templates that you can copy and then have your students use those templates as they're playing with circuits in the classroom. And that is basically it as far as our lesson on circuits goes. I'm really excited to see the types of cards that you might create. You can create a card with a simple circuit. You can use a series circuit where you've got 2 or more components in a row that you're going to light up. And that's what we've given you here, our components to light up. We don't have any motors, unfortunately, or any sound types of components in the bags, the maker kits that we gave you. So really, you're just dealing with these LEDs. And go out, have fun with it. Create either a simple, a series, or a parallel circuit. You can make name tags like my TAs did, or you can make a simple card, or you can make kind of a light up card and have some fun with that. As you go out and you play with circuits, it's a great way to explore and experiment. If you want extra credit and you really want to go above and beyond, you can actually program your microbit to send electricity to your circuit, and that will then maybe blink the lights or have the lights do different types of things as you send the electricity on and off or what have you as you connect a microbit to your circuit. So thank you so much. Go out and have fun, and we're super excited to see what you do with circuits.